This is a lesson on types of matter. There are two broad types of matter. One is pure substances, and the other are mixtures. Pure substances have a set percentage of types of atoms. Set percentage of types of atoms, so it doesn't vary, it's always such and such a percent. An element, and that's a structural definition. Structural means how it's put together. An element is 100% of one type of atom, which isn't structural, it's how it's put together. Functional definition would be how it functions or what it does. A functional definition of an element would be a substance that cannot be broken down into simpler particles. What's simpler and how can you break it down confuses things. So we're going to stick with element is 100% of one type of atom, and that leaves a compound as the other type of a pure substance, which has a set percent of two or more types of atoms, like NaCl. An element, what you can do is you can find it on the periodic table. If it shows up in the periodic table, it's an element. Compound, like salt or water or carbon dioxide, they have a compound, they have a set formula, CO2, H2O, NaCl. For example, NaCl is 50% sodium atoms and 50% chloride atoms. H2O, water, is 67% H atoms and 33% oxygen atoms. So they have a set percentage of the types of atoms all the time. The other type of substances we run into are mixtures. Again, doing a structural definition, they do not have a set percent of types of atoms. Functional definition, mixtures can be separated using physical means, whatever that means. I think it's very much more set on, or easier to define if you do a mixture this way. So mixtures do not have a set percent of types of atoms. Salt water is a mixture. It's made up of salt and water. How much salt? Can you have a teaspoon of salt in a cup of water? Tablespoon and a half, a pinch, a half cup? Yeah, those are all salt waters, and the percent of salt in the salt water can vary. It's still the same thing. Another thing you do on mixture is there different types, like glass. There's different types of glass, so glass is a mixture. You can have a homogeneous mixture, also known as a solution. Homo means the same, so it looks the same. Gatorade, Kool-Aid, air, the room. One part looks like the same as another part. So a homogeneous mixture is also known as a solution, and it looks the same throughout. And I gave several examples of that. Heterogeneous, hetero meaning, that's an E up here by the way, heterogeneous meaning different, looks lumpy. Lumpy solutions have differences in it. Heterogeneous would be a chocolate sundae. Homogeneous would be a chocolate shake. Heterogeneous concrete, where you have gravel parts and the cement parts. That would be a heterogeneous mixture. Vinegar and oil salad dressing. The oil part floats, vinegar part the oil part floats, the vinegar part is down below. So that's what it is. You can also have colloid and a suspension. They both exhibit the Tyndall effect, which means if you shine a light through it, it scatters the light, the solution glows. If you shine a light through a homogeneous mixture or a solution, it just passes through and nothing much happens. If you shine a light through these, the light scatters and the solution glows. So this is the Tyndall effect. So they both have that because the particles of the colloid are hundreds of atoms big. The particles in a suspension are thousands of atoms big. But the suspension, what it does over time, how you know the difference between them, the suspension will settle out the difference. These will settle, and a colloid does not settle. Milk is a colloid. Regular white milk, you won't see it settle to the bottom. Pulpy orange juice is suspension. You gotta shake it up before you do it. The theme of this chapter is medicine and antacids, and we talk about different types of medicines and why it is. Most medicines are a mixture because there's a tiny bit. If you have a 30-day supply of many types of medicines, you'd have a grain of salt. So rather than trying to find out 30 grains of salt in a vial, they pack it with filler, which makes it big enough so that you can handle it. Medicines are also sometimes suspensions. You can read, it's a suspension because on the package it says shake well before taking. A colloid, you can tell if the medicine's in a colloid or a suspension by shining the light through it, scatter. The homework assignment, I'm not going to do that on this. So this is a lesson on types of matter, and the lesson, the assignment will be given to you on the webpage.